Today I'll be talking about a very important, law from electrostatics, that is Coulomb's law. So the Coulomb's law is very simple. You may have, study about the gravitational force. Newton's law of gravitation is states that force between the two masses is directly proportional to product of their mass, and that is inversely proportional to square of distance between them, right? And in the same way, we have if we have two charges, let's suppose these are the two charges Q1, Q2, two charges. For example, if they are of a similar kind, so they will repel each other, right? They will repel each other. Let's suppose this is the distance between them. Okay, distance between them, and let this distance be r. So Coulomb's law states that the force between these two charges, whether that is repulsive force or attractive force, we know that positive positive they will repel each other, negative negative they will repel each other, and positive negative they will attract each other. So this electrostatic force, it can be repulsive or it can be attractive, both. And as far as force of law is concerned, sorry, this as far as gravitation law is concerned, it is only the attractive, right? Coulomb's law states that F is directly proportional to Q1 Q2, magnitude of Q1 Q2, right, divided by R square. So Q1 Q2, they are the two charges, and R, this is the separation between the two charges. So here it is clear that this force is inversely proportional to R square. So this is inverse square law, right? Inverse square law, as is the gravitational force. So if I remove this proportionality sign, so a proportionality constant is introduced, K, Q1, Q2 divided by R square. This K, it's called electrostatic constant, okay, or electrostatic force constant, electrostatic force constant. And its value is K is equal to 9 into 10 raised power 9 Newton meter square per Coulomb square. So this is the unit of this K. And we also write K equal to 1 divided by 4 pi epsilon naught, right? And where this epsilon naught, this is the absolute electrical permittivity. This is absolute electrical permittivity of free space. Okay, free space. Because if we change the medium, the force between the two charges also gets changed, and the force is maximum in free space. So this epsilon naught, it represents the electrical permittivity of free space. So I can write F equal to K. Instead of K, I will write 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square, right? Let me call this as equation first. So from this, I may write the epsilon naught. I can write the epsilon naught as, okay. So I can write the epsilon naught from the first equation, epsilon naught equal to 1 divided by 4 pi F, right? 1 divided by 4 pi F Q1 Q2 divided by R square. Okay, and from this I will derive the SI unit of this epsilon naught. So epsilon naught will be equal to 1 divided by F. So that is Newton. The SI unit of force is Newton. And Q1 Q2, so we have Coulomb for Q1 and Q2 for Coulomb, divided by, for R, and this is obviously distance, so it is meter square. So our unit is Coulomb square per Newton per meter square. So this is the unit of this epsilon naught. Okay, so let's talk about the dimensions of epsilon naught, this free space, permittivity of free space. So for Coulomb, we have this AT, right? We have AT dimensional formula, and again because there are two here, Coulomb, so AT divided by, and for this Newton, this is force actually, we have dimensional formula mLT minus 2, and for meter we have L square, because this is meter square. So this is the dimensional formula for this. Okay, and from here I can write the K equal to 1 divided by, this is 4 pi epsilon naught, right? So from here epsilon will be equal to 1 divided by 4 pi K. Okay, and I can write the value of K as this epsilon naught as 1 divided by 4 multiplied by 3.14 multiplied by, we have value of K equal to 9 into 10 raised power 9. Okay, and if we calculate this, our value comes out to be 8.85 multiplied by 10 raised power minus 12. And for epsilon naught, we have this unit here, this Coulomb square, right? Coulomb square per Newton per meter square. So this